Hey there, future scientists. Today, we're exploring the awesome realm of motion and forces. Imagine you're sitting serenely and suddenly you're on the move. What's the invisible force that caused that action? Well, it's not magic, it's something we call force. Force is a fascinating concept that can be thought of as a friendly push or pull. It's this unseen energy that makes things move, or conversely, brings them to a halt. So whether you're sailing down a slide or stopping to catch a ball, force is at play. Now imagine you're in the 17th century and you're Sir Isaac Newton. You're about to come up with 3 fundamental laws that will change the way we understand motion and forces forever. But that's a story for another scene. Before Newton, people had different beliefs about force and motion. They didn't have the same understanding that we have today. Now let's delve a little deeper into the world of mechanics. It's not just about fixing cars. In the science world, mechanics is the study of motion and forces. It's split into 2 parts: statics, which is all about things that are stationary, and dynamics, which deals with things in motion. But wait, there's more. Let's add kinematics and kinetics into our mix. Kinematics is like watching a ballet dancer pirouette without wondering why she's spinning. It's all about describing motion without considering what's causing it. On the other hand, kinetics is like being the detective in a mystery novel. It's all about figuring out what's causing things to move. So, there you have it. A whirlwind introduction to the captivating world of motion and forces. We've barely scratched the surface, but hopefully this has piqued your curiosity. It's not magic, it's something called force. Think of it like a friendly push or pull. Now let's talk about a legendary scientist named Sir Isaac Newton. He had 3 special rules about motion. Newton, the English physicist who revolutionized our understanding of the physical world. His insights into the nature of motion and force have shaped centuries of scientific thought and discovery. Newton's first law of motion, often referred to as the law of inertia, states that an object at rest will stay at rest, and an object in motion will stay in motion, unless acted upon by an external force. Picture a soccer ball on a field. It's not going to move unless a player comes along and kicks it. That's Newton's first law in action. The second law of motion is all about how force, mass, and acceleration are related. In simple terms, Newton's second law tells us that the more force you apply to an object, the faster it will move. And if that object happens to be heavy, you're going to have to use more force to move it. Imagine trying to push a car compared to pushing a bicycle. The car requires much more force to get it moving because of its greater mass. And finally, Newton's third law of motion famously states that for every action, there is an equal and opposite reaction. That means if you push a wall, the wall pushes back with an equal amount of force. It's why you feel a recoil when you release air from an inflated balloon. The air rushes out in one direction and the balloon is propelled in the opposite direction. These 3 laws form the foundation of classical mechanics, and they have broad applications from helping us understand the orbits of planets to designing vehicles and buildings. Newton's laws of motion help us understand how things move and why. But before Newton, people had different ideas about force and motion. We've come a long way in our understanding, and it's thanks in large part to the pioneering work of Sir Isaac Newton. Mechanics is the fancy term for studying this stuff. There are 2 parts: statics, which is about things staying still, and dynamics, which is about things on the move. Let's start with statics. Picture a book resting on a shelf or a car parked on a hill. Neither the book nor the car is moving, but there's still a lot going on. Forces are keeping them in place. The book is being pulled down by gravity, but the shelf is pushing back up with an equal force. That's why the book stays put. Similarly, the car stays parked on the hill because the brakes apply a force that balances out the pull of gravity. Now let's switch gears and talk about dynamics. Think of a soccer ball being kicked across a field or a rocket launching into space. These are examples of objects in motion, and that motion is due to forces. When the soccer player kicks the ball, they apply a force that sets the ball in motion. In the case of the rocket, the force of the engines propelling it upward has to overcome the force of gravity pulling it down. In both statics and dynamics, it's all about balance. When forces are balanced in statics, objects stay still. In dynamics, When forces are balanced, objects keep moving at a constant speed. But when forces become unbalanced, that's when things start to change. An unbalanced force in statics might cause a structure to collapse, while in dynamics it could speed up, slow down, or change the direction of a moving object. You see, whether it's a skyscraper standing tall or a spacecraft hurtling through the cosmos, the principles of statics and dynamics are at play, helping us understand and predict how things behave. And that's just a taste of the fascinating world of mechanics. There's so much more to explore, from the tiniest atoms to the vastness of the universe. Statics is about things staying still, and dynamics is about things on the move. What's the difference between kinematics and kinetics? Now that's a question that gets the gears turning. Let's delve into these intriguing components of mechanics, shall we? First off, kinematics. This is the aspect of mechanics that's concerned with pure motion, and it doesn't bother itself with what's causing that motion. Think of it like narrating a race without any insights into what's powering the cars. You're detailing the speed, the direction, the distance traveled, but you're not taking a look under the hood. You're not concerned with the engines, the fuel, or the driver's strategy. You're simply describing how the cars are moving. Now let's shift gears and step into the world of kinetics. This is where we start to ask why. Why is this object moving? What's causing it to speed up, slow down, or change direction? In our race analogy, kinetics is like taking a deep dive into the engines of the cars, understanding the combustion of the fuel, and analyzing the driver's tactics. It's all about studying the forces that cause motion. So in essence, kinematics and kinetics are two sides of the same coin, each offering a unique perspective on the fascinating study of motion. While kinematics gives us a detailed picture of how things move, kinetics goes one step further and seeks to understand why things move the way they do. It's the interplay between these two aspects that makes the study of motion so incredibly intriguing. From the simplest push of a swing to the complex movements of celestial bodies, kinematics and kinetics work together, helping us make sense of the world around us. They're integral to everything from designing efficient machines to predicting the paths of rockets. So the next time you watch a leaf fluttering in the wind or a soccer ball sailing into a goal, remember there's a whole lot of science happening right before your eyes. Kinematics is like describing motion without thinking about what it causes, while kinetics is all about figuring out what makes things move. And that's a wrap on our quick journey into the world of motion and forces. We've covered a lot of ground today, diving headfirst into the fascinating world of physics. We've discovered the magic behind the simple act of moving, and it's not a spell or a sorcery, but the incredible power of forces. Remember, forces are those friendly pushes and pulls that set us in motion or bring us to a halt. They're the unseen hands that guide the dance of everything around us, from the smallest atom to the largest galaxy. We've also met a legendary scientist, Sir Isaac Newton, and his 3 special laws of motion. These laws are the cornerstone of our understanding of how things move and why. They've shaped our knowledge of the universe and continue to guide scientists and engineers in their work today. We've delved into the two sides of mechanics, statics and dynamics. While statics is all about the calm, the still, and the unmoving, dynamics is the study of things in motion, the active and the energetic. And then we've differentiated between kinematics and kinetics. Kinematics, the description of motion without worrying about what causes it. And kinetics, the investigation into what makes things move. In this whirlwind tour, we've just scratched the surface of the vast and intriguing realm of motion and forces. But don't worry if you haven't grasped everything in one go. It's a lot to take in, and the beauty of learning is that it's a journey, not a race. So as we wrap up, remember that questions are the starting point of all knowledge. If you have any queries or thoughts, or if there's something you're curious about, don't hesitate. Let your questions be the spark that ignites your quest for knowledge. Any questions, feel free to ask in the comments below.